So I'm going to be basically implicitly covering several aspects of what AWTG is doing also within the connected vehicles area through a number of past projects, but strongly related to that is, of course, the kind of communication capabilities. And there's a number of projects that we're working on, particularly in Scotland, that could be very relevant to use cases that people might want to trial. So there are two aspects here of communications: 5G and Wi-Fi. So to give an overview of those first. So 5G is actually key to vehicular communications from a number of perspectives. So there's the issue of latency, which is vital to a number of use cases. Sorry, while I just manage the panel here. So 5G strives to achieve much lower latencies, which is vital for aspects such as the, for example, remote control of vehicles, inter-vehicle communications. Is another aspect there. Associated with that is also the aspect of reliability and the ability to basically guarantee the communication, the quality of the communication. There's much higher data rates supported by 5G. So we're talking the range of hundreds of megabits plus, and this is relevant to the ability for vehicles to exchange sensor information, LiDAR information, for example, but can also assist the streaming of information from vehicles, so akin to a lot of the stuff that Bryn was talking about for Formula One. As well as enhancements in support for mobility, there's and higher mobilities, again relevant to communications to Formula One. There's also far better performance at each given mobility. There's improvements in connection density, so a order of magnitude increase there. And this is relevant again in terms of the ability to communicate not just with vehicles, but with the various forms of roadside infrastructure, and within the even communication with specific sensors in vehicles. So there are a number of benefits that 5G has that make it again key to vehicular communications, and it is also becoming viable in the UK through the recent auction of the lower frequency spectrum, which is going to be vital to achieving the widespread coverage for 5G. And the remainder of the mid frequency spectrum, which will be vital to achieving the very high capacities for things like the video streaming from vehicles that I referred to previously. So 5G and cellular is becoming key to vehicular communications and becoming viable. Wi-Fi still is key. So IEEE 802.11p, which is the basis of the distributed short-range communications in the US and ITSG5 in the EU, communication protocols and stack between vehicles is basically being updated with a number of additional functionalities, and this is a key development from the Wi-Fi side. So it's going to support additional bands for very high data rates communicating between vehicles, double the throughput at least, and this is only at the lower frequency 5.9 gigahertz. Higher mobility, lower sensitivity, hence longer range. And positioning, and it will be backward compatible with 802.11p, so it's not going to invalidate the past work that has been done in ITSG5, for example, in the EU and UK. And it's also going to support interoperability and coexistence with the range of other systems. So this is, again, one way of emphasizing that Wi-Fi is going to remain key, particularly for the vehicle-to-vehicle communication aspects, but also others. So some scenarios for vehicular communications, I guess everyone on the call is familiar with a number of these, but of course there's communication with roadside infrastructure, for example, to adapt to the timing of traffic lights based on the presence of vehicles. You don't want to waste a massive amount of energy by stopping a massive truck, for example, unnecessarily if there's no traffic, other traffic at the junction. You could change the traffic lights to green. There's a lot to be done on communication for charging optimization or energy optimization and energy efficiency. So the concept of prosumers and the ability to sorry, my daughter's just joined. I'm going to quickly deal with. Okay, apologies for that. I'm trying to manage a family situation here.
All good.
But the yeah, so there's a lot to be done on basically managing the smart grid and infrastructure for charging vehicles, because there are vast energy demands of vehicles, and these are moving demands. So you can actually, for example, charge in a location where there's less demand, and theoretically, eventually, the cost of the electricity will be less, or at a time, for example, overnight, with economy 5 tariffs, and then share that energy at locations you're going to be throughout the day. So you have the ability to actually become a prosumer and make money potentially through this, but just in general manage the vast energy demand that there's going to be on the grid. There's of course communication between vehicles. So in a 5G and both the updates to Wi-Fi context, the ability to transfer sensor information, potentially even very high data LiDAR and video, other forms of sensor information to better manage collision avoidance, be able to see in front of the vehicle in front of you. Also for other uses such as platooning of vehicles to manage the air resistance drag in large convoys of transport, for example. Pedestrian avoidance, so communicating, particularly relevant on a 5G, in a 5G context where you'll have pretty much all pedestrians with some form of mobile connectivity. The ability to communicate between vehicles and pedestrians, likely through some kind of server to manage potential collisions that could happen, and for example, alert pedestrians. There's in 5G in particular a very strong involvement of the edge cloud and the ability to bring processing and applications very close to the end user. And there's a lot of work ongoing on vehicular remote control linked to that as one possibility, and the storage of context data and processing of context data, for example, through AI, which might assist in managing the roadside infrastructure, for example, in being able to predict where and when vehicles are likely to manage the roadside infrastructure based on the traffic loads. And again, not have people waiting vast amounts of time at red lights when it's unnecessary. And of course, there are maintenance aspects, things like upgrades, software upgrades, and again, the vehicle-to-vehicle communication aspects can be, and improvements can be relevant also to that in terms of sharing such updates directly between the vehicles, as well as generally through the connectivity and the cloud. So AWTG is working extensively on a number of vehicular scenarios, communication aspects, but also use cases. So Millbrook Vehicle Proving Ground is an obvious example, which has progressed also to the Culham deployments. AWTG is also working very extensively as the deployment partner for a number of projects in Scotland. So one very prominent one is Dundee. And I've put this here just to highlight that we have very good coverage 5G network with a couple of base stations being deployed in the waterfront area, and that could be relevant to testing many of these capabilities. And it's designed such that there is line of sight from the base station to a vast number of locations. So again, it's going to be kind of at or close to the pinnacle of what 5G could achieve through these areas. We have also a large number of Wi-Fi access points being deployed, again, in the same coordinated system. And this is quite closely integrated, actually, with the transport system and infrastructure within Dundee. So there is definitely potential to look at and build on that for vehicular use cases. And another example that we're directly doing, as opposed to there are further ones as subcontractors, but another is just south of Dumfries at the Crichton site. So there is definitely opportunity here for potential low speed use cases to be investigated. So, for example, pedestrian avoidance or alerting pedestrians based on the presence of vehicles, etc. So both of these we would need to discuss in a lot more detail with the various clients if it was to be taken forward, respectively, Dundee City Council and the Scotland 5G Centre. But to highlight that, again, there are opportunities out there linked to 5G, particularly, and Wi-Fi in the context of Dundee as well. So that's all from my side. Any questions, or I guess they're at the end?
Yeah, we'll do. Yeah, we may not even have time for questions, but Oliver, there is one very specific one, I guess. I think it's a question in the chat there, maybe if you want to jump onto that. But I mean, yeah, it sounds like are there any particular use cases that 5G is enabling that you're coming across that, the industry is becoming more interested in? Or are you still at the stage where we're still working out the standards and the implementations?
So again, one key one would be role of vehicles and the ability to not just in terms of positioning vehicles, optimization of schedules, for example, in the case of taxis, autonomous taxis, and autonomous public transport, but the ability to actually receive for example, information on the impulses that vehicles are experiencing and adapt according to those. That's one very particular area. So we're talking about haptic kind of information, the forces that are experienced, potentially aspects such as the vibration, and that might indicate aspects such as the contact of tires with the road. So because of the low latency aspects, the very challenging requirements in terms of delay for being able to receive and react to such information can also apply in the vehicular context, and we are seeing that as a use case. So the other one, initially at least, given the initial kind of focus on 5G networks, is the vast capacities that 5G can achieve, and again the ability to convey sensor information. So things like LiDAR, the camera outputs from videos from cars. That's a couple of initial focus areas, I guess.
Yeah. So those are ones that we should be able to trial and test and do pilots on in these test beds in the near future.
Yeah. So initial 5G deployment, including ours with the most prominent manufacturer. I probably shouldn't mention any names, but they're all focused on this very high data rate capability. So things like, again, the streaming from vehicles, between vehicles, would be the main focus. The systems likely towards the end of this year are being upgraded to support better ultra reliable low latency communications. And that's where things like latency and the reliability aspects will become more prominent.
Yep, the safety use cases, I guess.
Exactly, yeah.
Yep.
That's great.
Okay, excellent. Well, thank you very much.